Hello learners, and welcome to our final lecture about aqueous ionic equilibrium. I lost my voice over the weekend and was kind of going in and out, so I do apologize in advance. So final part means new pre-lecture, folks. That means you want to complete the pre-lecture one-pager to orient your brain. You want to review previous information by reviewing a concept and completing a practice problem related to the concept. And of course, the goal of the lecture is to enhance or add to the pre-lecture information. So let's get to thinking, folks. So recall from Chem 101 and Chapter 4 that a compound is considered soluble if it dissolves in water and insoluble if it does not. Therefore, with the solubility rules, we were able to classify ionic compounds simply as soluble, forming ions, or insoluble, forming a precipitate. But it was never perfect because we were never able to fully describe slightly soluble compounds, and we would just consider those insoluble too. Well, now we do have the tools to examine degrees of solubility for those slightly soluble ionic compounds by applying the concept of equilibrium. What are we applying the concept of equilibrium to? The process of dissolution. And dissolution means you're going to be dissolving a solid into its respective ions. For our course, we will assume that the small amount of slightly soluble ionic compound that does dissolve dissociates completely into its ion. For example, we can represent the dissolution of calcium fluoride in water. So here we have calcium fluoride as a solid. It's in equilibrium to form its ions Ca2 plus and 2F minus ion. And we have a brand new chemical avenger, CaF2 fission, to represent this dissolution. Of course, at equilibrium, the rates of dissolving ions and precipitation reach a balance. And we actually get to use a new equilibrium constant, which we'll learn about later on. And since we're talking equilibrium, we're able to use Le Chatelier's principle to understand shifts of presence of a common ion or even changes in pH, for example. We can then go further and control the degree of solubility through a process called selective precipitation. And then finally, we'll learn about complex ion formation. So we're bringing back complex ions, folks, and its influence on solubility. And we, of course, will use some OG chemical avengers and some new ones to explore this section further. So let's get organized, folks. For this last part, we will jump right into what it means to be a slightly soluble ionic compound and dive into calculations for our new equilibrium constant called the solubility product constant, or KSP. Next, we return to Le Chatelier's principle and learn about the effect of common ion and pH on solubility. We then dive deeper into predicting precipitate formation and learn about selective precipitation of ions. Next, we focus on the relationship between complex ions and solubility, also called coupled equilibria. And finally, as a bonus, we get to witness the chemical avengers save equilibrium. So let's finish up this conversation, folks.